Hello class, I am working out of your Algebra 2 book, 6.1 Quadratic Functions. In a little while we will do number 21 and 27 out of your actual assignment. Before we start, let's look at some basics of a parabola. If I plot a point at -1, -4, and we draw a parabola from it, we have several components of this graph that have terminology attached. So let's think about what that looks like. At -1, -4, the bottom of the graph, we have a vertex. So we say that. Because the graph goes up, we also have at this point a minimum value. That is the bottom of the graph where the highlighted line is. Minimum value. Okay. We have something called the axis of symmetry, and it is a line right down the middle of the graph of the parabola, almost like a bisector. That is at x equals -1. We'll be asked for domain and range. Domain are all of the x's. So if we look at this graph and we think about the x-axis, technically this parabola would go on forever and ever and ever and ever and ever, and eventually spread out somewhat and could go infinitely to include all negative and positive numbers on the x-axis. So that means the domain for this parabola is the set of all real numbers, or you could say -infinity to infinity. If the domain is all the x's, then the range are all the y's. So the range would include what we see on the y-axis until the graph stops. And it stops at a -4. It does not include anything on the y-axis below -4, but it can infinitely include anything on the y-axis above -4 and including -4. So we say that in set notation. The range is the set of y such that y is greater than or equal to -4 in set. We'll look at number 21 from your assignment. You are asked to look at the function equation. So the function of x is x squared minus 2x minus 1. The squared term gives you a clue that it is some kind of parabola on the graph. And we are asked to plot at least 5 points to graph this function. So make a t-chart of x and y. Hover around 0. You might start with -1, 0, 1, 2, and 3. If we substitute -1 in for all the x's in the function of x, we can kind of mental math this. You're going to get from the input -1 an output of 2 for y. At 0, you'll have a y of -1. At 1, we'll have -2 for y. At 2, we'll have -1 for y. And at 3, we'll have 2 for y. All right, plotting these points. We move over to the graph and we start plotting those at -1, 2, 0, -1, and my points are going to be a little bit like lines because of my stylus. At 1, -2, 2, -1, and 3, 2. We do see some kind of parabola emerging here. So that makes sense. And we have plotted 5 points and graphed the function based on the instructions. If we move on to 27, we're asked to do a little bit more than that. We will also find points to plot, and then we will use some of our terminology for parameters of a parabola. So we looked at it first. So in number 27, we have the function of x equals -2x squared. And we are not only asked to plot 5 points, but also find the vertex, the maximum or minimum, and to refer to our chart on page 328, which we need to look over to determine the effect on the graph from the function that we're given, if it's flat or steep. So if we start by plotting our points from a x and y t-chart, we could hover around 0 for input x at -2, -1, 0, 1, and 2. And at -2, y would be -8. Try again. There it is. And at -1, we would get -2 for y. At 0, that's easy, it would be 0. At 1, we would get -2. And at 2, we would have -8. Plotting these points on the graph, you notice the origin 0, 0 right away. -2, -8, somewhere down here. -1, -2, it's about right here. We have our 0, 0, 1, -2 is here, and 2, -8 is here. An upside down parabola. Okay, we're asked for the vertex, which is where the graph is at the top or the bottom. You see that's at the origin. Also, we call this the maximum value because on the x and y plane, it is the top of the graph. So it's the maximum value of the parabola we are graphing right now. So our vertex is at 0, 0, and it is also our maximum value. We're also to state whether the function's graph is steeper than, flatter than, or the same shape as an original parabola graph. We would consider that to look like this. Do that in light green. At f of x equals x squared, this is the basic graph that every shift in translation comes from. So there is a chart on page 328 that determines what happens with any graph not graphed as a basic function of x equals x squared. So we have one here, and on that chart on page 328 we have, because of the -2 in the function, that our graph and the absolute value of -2 is greater than 1 is steeper than the original base graph. We could do domain and range. We are not necessarily asked for domain and range, but just to practice. For the domain, all the x's, if we looked at this, technically our graph would go on and on and on and on and on forever, both on the negative and the positive side of the x's. So our domain is the set of all real numbers for the graph we have here. And then we would talk about the range. The range is all the y's. So if we think about all the y's, you see our graph stops at 0, 0, and it is in the negative side of the plane for the y's. So the range would be y such that y is less than or equal to 0 for the range, because it would include 0 with an equal sign and be all the negative numbers on the y-axis. I hope this helps in determining parts of a parabola. Study your chart on page 328. Kind of memorize what happens in the function to make the basic function of a parabola graph steeper or flatter. I hope this helps you, and I will see you soon.